In this lesson, we are going to introduce the concept of rates of change in calculus. Our goal is getting familiar with the concepts of rate of change over an interval, which is called the average rate of change, and rate of change at a point, which is called the instantaneous rate of change. By definition, the average rate of change of f of x over the interval a and b, which is denoted by a rock of f of x when x is between a and b. In this lesson, we are going to introduce the concepts of rates of change. Our goal is getting familiar with the concepts of rate of change over an interval, which is called the average rate of change, and at the point that is called the instantaneous rate of change. By definition, average rate of change of the function f of x over the interval a and b, which is denoted by a rock of f of x when x is between a and b, is f of b minus f of a divided by b minus a. If you look at the graph of f of x and assume the endpoints are a and f of a and b and f of b, then f of b minus f of a divided by b minus a is the slope of the line joining the endpoints. It is called the secant line. Therefore, the geometric interpretation of the average rate of change of f of x over an interval is the slope of the secant line joining the endpoints of the interval. Let's have an example. We want to find the average rate of change of f of x equals x2 plus 3x over the interval 1 and 3. A rock of f of x when x is between 1 and 3 is f of 3 minus f of 1 divided by 3 minus 1. F of 3 is 3 to the power of 2 plus 3 times 3, which is 18. F of 1 is 1 to the power of 2 plus 3 times 1, which is 4. Therefore, the average rate of change of f of x over the given interval is 18 minus 4 divided by 3 minus 1. That is 7. By definition, limit of f of x minus f of a over x minus a as x approaches a is called the instantaneous rate of change of f of x at x equals a, and it's denoted by I rock of f of x when x is a. This can be defined as follows. I rock of f of x at x equals a is limit of f of a plus h minus f of a divided by h as h approaches 0. Both of these definitions are based on creating an interval between a and x, which is a plus h, and finding the average rate of change of the function over this interval as h approaches 0. If we look at the geometric interpretation, we'll see as h approaches 0 or x approaches a, the secant line is changing to the tangent line. Therefore, the geometric interpretation of the instantaneous rate of change is the slope of the tangent line to the graph of y equals f of x at x equals a. Let's have an example. Determine the instantaneous rate of change of f of x equals x3 plus 1 at x equals 3. By definition, IROC of f of x at x equals 3 is limit of f of x minus f of 3 divided by x minus 3 as x approaches 3. F of x is x3 plus 1. F of 3 is 28. Therefore, the limit would be the same as limit of x3 minus 27 divided by x minus 3 as x approaches 3. x3 minus 27 can be factored as x minus 3 times x2 plus 3x plus 9. Therefore, the limit would be the same as limit of x2 plus 3x plus 9 as x approaches 3, which is 9 plus 9 plus 9, 27. This means the instantaneous rate of change of f of x at x equals 3 is 27. Geometrically, it means the slope of the tangent line to the graph of f of x equals x3 plus 1 at x equals 3 is 27. Let's recap. In this lesson, we learned the meaning of average rate of change, which is rate of change of a function over the given interval a and b. It is f of b minus f of a divided by b minus a, which is the slope of the secant line joining the endpoints of the given interval. We also talked about the rate of change of a function at a given point, instantaneous rate of change of the function f of x at x equals a. We defined it as limit of f of x minus f of a divided by x minus a as x approaches a. We had an alternative definition for AROC as well. And we saw geometrically the instantaneous rate of change of a function at a given point is the slope of the function, the slope of the tangent line to the graph of the function at that point. Thank you.